This conference will now be recorded.
Hello everyone. Good morning, good afternoon, or good evening as per your locations. So yesterday we discussed about the file editor, which is VI or VIM editor. Now let's move ahead and let's see some other types of files that we come across in Unix or Linux environments. Okay, so let me first of all log in. Now, as you see in your current location, there are lots of files. So we discussed that if the file start with dash, that means it is a normal, regular file. But if it is starts with D, that means it is a directory. Now, same way, there are other types also. If the file starts with L, that means it is a link or shortcut file, right? And if it is starting with B, it's a block file. See, what happens in Unix usually is for us, everything is a different entity. For example, we have a file, something different. You have a directory, that is something different. You have software, that is a different entity. You have hardware, that is different entity. But for Unix, everything is stored in the form of file. So Unix sees everything as a file. Normal file, it is a file. Directory, it is a file. Hard disk, it is a file. Floppy, CD, everything is a file. Printer, scanner, everything is file. So the universal rule of Unix is for Unix, everything is file. So it stores everything in the form of file for its reference. So suppose you have hard disk, floppy disk, this is represented as block file, the file that has blocks to store the data. Then keyboard, mouse, and the screen is character special file where characters are printed and you can type the characters over there. So there are many such examples I can show you. For example, if you go to ls-l/dev, maybe a file is there, SDA. Now in this, you can see that the file is starting with an alphabet B. So what does that means? It is a block file. So it says that it's not a normal file, it's a disk file. For us, it's a disk. But for Unix, it's a special file, block special file, right? Same way, you may have some character special files also, like some terminal, which starts with C. So terminal is nothing but the screen on which the letters are printed, your screen, right? So this is the way how you can identify that what are the different types of files. So you have a normal file, you have a directory, you have a link file. So link is nothing but shortcut, which we are going to discuss the next thing. Then block special files are nothing but your hard disks or partitions or CD drive, floppy drive, in which you can store data. Then you have character special files, keyboard, mouse, or the screen on which the characters are getting printed. Those are stored in the form of character special file. So this is the way how different types of files are recognized in Unix environment or Linux environment. Now, as we talked about links or shortcuts, let us try to talk about how many types of links do we have and what are the difference between these links. So we have two types of links, soft link and a hard link. In a very simple explanation, soft link is nothing but a shortcut file. Now you might have done that many times in Windows, that original software is installed under C drive program files folder. Now every time I don't want to go to C drive and program files and access it, so I'll create a shortcut and that shortcut will be pasted on desktop. So when you click the icon on the desktop, automatically it goes to that location and open the software for you. So that is called a shortcut file. Original file is somewhere in the deep different location, but we have created a shortcut somewhere from where we can easily access the file. So that is nothing but your shortcut file. Now, the size of the link, we'll discuss about that thing. Second point is can be created across the partitions. Now, for example, in your system, you have two partitions, C drive, D drive. So in C drive, you can keep your original file, and in D drive, you can keep the link file. Okay, so you can keep the shortcuts across the platform wherever you want, right? Inode number of source and link file is different. First of all, let me tell you what is inode number. Inode stands for index node. Guys, when you take any book, even our lab manual also, you can see first or second or third page is having an index page, which keeps the information that which topic is available on which page number. So don't you think that index page is important for reading a book? It tells you to go directly to that page number and find the topic you want. If there is no index page, how complicated it would be to find a topic every time. Same way, you have a hard disk. Now, hard disk is a big thing. It stores the data in different locations of your hard drive. Now, whenever I'm trying to search that file, read the file, it would become difficult for me to access the file wherever it stores the data. So what happens is every file you create or directory you create, with that file, there will be an inode attached to it, index node. What that inode will do, it keep the address of the location where the file is kept. So whenever you are trying to read a file, that inode will tell that here is the location on which that file is stored, and it helps you to add more data, access the file, who is the owner of the file, who is the group owner of the file. Total information about the file is stored in inode. So basically, inode is added to a file in order to make your accessing the file easy on the hard disk. So that hard disk may store your data anywhere, different locations. This inode will keep the address, and whenever you are searching or reading the file, with the help of inode, physically that file will be found and added the data into that. So every file will have an inode number, inode attached to it, and inodes will have a number. So here it says that original file and the link file both will have two different inode number. Original file will have a separate inode number and link file will have a separate inode number. If the original file is deleted, then the link is broken and data will be lost. So what happens if the original file, suppose you have kept the original file in C drive and you deleted that original file, the link what you kept in D drive will be of no use because link never carries any data. It is only a pointer. It's a shortcut. By using it, you're accessing your original file. Now, when I show you practically, it becomes more clearer. So let us say that in my directory, I'll create one file. So let me go into my dir and let me create a file. For example, I'll call it my test, or I'll create it with VI editor so that I can add some data to it. So I'll say hello world. This is a test for link file. Let me save and quit. So guys, originally your file is, sorry, my test. Originally your file is present in my directory. Just check the full location. The full location says that in/root inside my dir there is a file my test. Now, guys, every time if I have to read the file or if I have to make the changes in the file, I need to first go into root. Then from root, I need to go into test or my dir. Inside my dir, I need to access my file, that is my test. So I don't want to go inside that directory and access it all the time. I want to keep a shortcut somewhere so that whenever I need, I just access the shortcut and it will take me to my original location. So how can I do that? You need to create a link file. To guys create a soft link, we have a command ln-s where s represents soft link source file. Now here is a really important thing. Source file you have to give complete address. If you don't give complete address, then your link will not be created perfectly and you will have issues. Okay, so you need to give slash root inside it, my directory inside it, my test. That's how the complete address you should give if you want the link to work properly. Then followed by destination wherever you want to keep it. As I told you, you can keep it at any location, different directories, different partitions, wherever you like. So I'll go for, as you see in the current location, there is no soft link file. Original file is present under my dir with the name test. So I'll say ln create a soft link for the file. I need to give complete address to avoid problems. So I'll say in slash root. See, complete address is called as absolute path. Absolute path always starts with slash, the mother directory, right? So we need to say ln-s. In slash, there is root folder. In root folder, there is my dir. Inside it, I have my test file. For this file, I want to create a link file in my current location where I am right now. I am in slash root. So in that slash root, I want to create a link with what name? Maybe soft. So original file is present here and the shortcut is created in the current directory. Now, as soon as you say ls, did you see there is a file with green color? So color coding is really helpful. It's not black or blue, it's green, a bluish green. Now, if you just check it out, ls-l soft, it says I am a link file. You see it is starting with an alphabet L, which represent that this is your link file. So you see your original file is pointing towards this file. It is telling the address that if you are reading me, you are actually reading this file. What's the complete location? How many characters does it have? First slash, then root, total 5 characters, then slash 6 character plus 5, 6 plus 5, 11, 11, and then you see I have one more slash 12, 12 plus 6, 18. What is the size of this file it is showing? The size of the file is 18 bytes. So you see over here, this was the point what I'm trying to convey. Size of the link is equal to number of characters in the name of original file or in the path of original file. So the path of original file has 18 characters. That is the reason it has taken 18 bytes as a size. So size of this file can be ignored because it is not originally holding the data. It is pointing to this location. If you check original file size, go to my dir and soft. Sorry, not soft. It is my test. Original file size is how much? 42 bytes. But link is showing 18. How it got 18? If you just count the characters starting from slash till my test, there are 18 characters. So that is the size what it took. So that 18 is nothing but the number of characters till it reached to the name. So originally your link file does not carry anything. So that size doesn't matter. It don't have any data inside it. It is only pointing. If you read cat inside my directory, my test, you see it has a data. Now you read in your current location soft file. I'll say cat and soft. Do you see same data? So actually when you say cat and soft, it is taking you to my directory and my test, reading it. Now if I make changes in the original file, I'll say vi editor, go to my dir and open my test. You can add a new line. For example, I'll add original file changed. Let me save and quit. In which file I made the change? I went to my dir and updated my test. Now you just read soft. Did you find the same change here? If you read original file, obviously original file will also say same data because data is getting updated in my test. Now let's see the sizes. I'll say ls-l, go to my directory and show me the size of my test. It's changed to 63. Now you check the size of soft, it will be always 18, right? So whenever you are making the change in original file, it will just be pointing to original file. That's it. Your link file is not going to have anything inside it. It is just a pointer. You are reading it, it is taking you to original file. It's a kind of escalator or elevator which is connecting you to your floor like that. Now, if I update the soft link, suppose I'll say vim soft and let me add, I'll say soft link updated. Let me save and quit. I added one line and I'm saving and quitting that file. Now, if you read the link file, your file is updated. Now you read the original file. Where is the original file? In my dir with the name my test. Did you see that same change is updated? Check the sizes, guys. I'll say ls-l my test. See, the size of original file is getting updated. Why? Because original file is getting updated. Data is stored in original file. Now, if you read the size of link file, it will still be stored at 18. There will be no change in the size of link. So whatever we are doing, it is getting updated into original file. Link is just a pointer which is taking us to original file. I don't have to go with cd, open the file and edit it. Directly I can say vim or cat, it will read that original file for me. Where it is helpful, when suppose your original file is situated deep inside directories and directories and directories and directories. So if I have to go 5 directories inside and read the file, it would be complicated always. So I'll create a link at my simple first location. So from that location, whenever I access the soft link, it will automatically go to deep inside and open that file for me. For that access, we prefer going with soft links. Okay. All right. Now, if original file is deleted, what will happen? So I'll go and delete. I'll go to my dir and I'm going to delete my test. I'll say rm-f my test. Original file is deleted. Yes. Come back to your home directory and see the color of soft. It turned to red. What does that means? If you try to read it, it says I'm not able to find original file. I'm missing the link to original file. Now you try to read the link file, it says no such file or directory. So guys, data was never stored in a soft link. Data is always stored in your original file. Okay, and one more point I missed out, the inode number. How to check inode number? You can say ls-i and the file name. So guys, here it is showing a different number, and before deleting, if I could have checked, the original file will show different inode number. Every file will have inode number. Now if you just check it out, you see each file is showing the inode number and no two inode numbers are same. If it is same, then it will be a different thing. But original file and link file will not have same inode number. Every file will have a different inode number. Now anyway guys, that link file is waste for me. I want to remove it. So you can say rm-f and the file name, that link file will be gone. See, if original file is there, link file is deleted, there is no data loss. But if original file is deleted, link file is present, then link is no use for you, right? Okay, now let us see hard link. Now, hard link is a very interesting kind of concept. In hard link, we have a concept of backup. So observe it carefully. It might be useful in many cases. So hard link is actually a backup file, linked backup file. Very interesting. Size of both files will be same. Now, why size of both files will be same? Because both files individually will have data. So that's the beauty. When the original file is deleted, the other file will still contain your data. Now guys, there is one rule for creating hard link, that hard link cannot be created in two different partitions. That means if original file is in C drive, then the hard link should also be in C drive. It is not possible that original file is in C drive and hard link you can keep in D drive. Why is that requirement? The reason is here, guys. The reason is inode number of both the files will be same. So what happens, guys? Whenever, suppose I have a hard disk, in the hard disk, I have partitions. Now your original file is here, so it would be using original file, that partition, inode. Now, if you try to keep the hard link on other partition, it would be difficult for hard link to access the same inode number. That's the reason original and hard link both will be available in the same partition so that both can access same inode. So the link between both the files is inode. Inode will help you to access the data similarly from both the points. So whenever you try to add any data in original file, automatically hard link will be updated. Whenever you add the data to hard link, automatically original file will also be updated. So that inode is a bridge between both the files. It provides parallelly the data to both the files. Okay, so when I show you the practical, it would be more clearer. So keep in mind that hard link cannot be created between two different partitions. Original file and hard link file both should be present in the same location. In fact, in the same direct, if you create, it would be more better. So what I'll do, I'll create one more file over here. For example, I'll create a file with the name test, and I'll say hello world. This is a test for hard link. I'll press escape, then I'll give colon WQ exclamation. Yesterday we saw. So now I have a file with the name called test, which contains some data. Now I want to create a hard link for it. To create a hard link, before creating the hard link, guys, just check the details and inode number, both of the original file test. So this is the inode number and these are the details, and you see number of links, it is showing only one. Now I'll create a hard link. I'll say ln. See, for creating soft link, I have given -s. Now it does not require us to give -h to create a hard link. You just need to say ln. That's it. Don't add any option after it. For creating a hard link, you have to just say ln. Original file, and what is the name of the link file you want to create. Suppose I want to create a link file with the name hard. As soon as you create a hard link, just check ls-li. Earlier it was telling that I have only one, there is no links for it. But now you see it is telling you that yes, there is a link file for it. So it is showing two. Two means this file is having one more hard link for it. For soft link, it is not going to show you any such thing. Only for hard link, this number will change. Now, if you look the details of hard file, now if you do ls, you'll find that there is a file created here with the name called hard. Now, did you see guys, it is coming in different color, green color or something? No, it's behaving as if it's a normal file, right? Now, if you check the details of test, and now you check the details of hard link. First of all, you see both are using same inode number. Now, whenever you create a file and put the data into that file, this inode will be helping us to store the data in the file. So when you have a link, when you update test file, automatically with the help of same inode, hard file will be updated. When you update hard file, automatically test file will be updated because they are linked back file. If you update one file, other will be automatically updated, and both will have data. You see the size, it is also showing 42 bytes, it is also showing 42 bytes. Let us add some data to test file and see what will happen. So I'll go to vim test. I'll say new line added by original file. Save and quit. Now, if you read the file cat test, this is the change. Now you read cat heart. Did you find same line added here also? So when you update the original file, the hard link will automatically get updated. Observe the sizes. I'll say ls-li test. The size increased to 73 bytes. How about hard? Hard is also increased to 73. That means the data is getting updated on both the side. Now, if I update the hard file, I'll go to vim hard and I'll say, sorry, let me undo it and let me add a new line. I'll say new line added by hard link, right? Let me save and quit. Now you read the hard link, this line is added. Now you read original file, see the same thing is added. So what did you found with that? See, hard link is a linked backup file. If you update the original file, automatically the link file will also get updated. So they are linked together, but data is stored in two copies. Original is separate, copy is separate. If you make changes in one file, automatically the same changes will be updated to second file, which was not happening in a soft link. It was showing the data, but it was not storing the data, right? Now you see, if I remove the original file, rm-f, I'll remove test file. Now, did you find any change in the color of hard? No, nothing changed. It is still showing you that old stuff. You read the data, it stores the data. Now you look ls-li hard. You see number of links. Earlier it was 2, which is now reduced to 1. So this is the way, guys, how we work with soft link and hard link. So what is the difference? Soft link is nothing but a shortcut file. Original file is somewhere deep, deep, deep inside many folders. Now, every time to make the changes or read it, you don't want to go so deep inside it. So we create a soft link and keep it at the top so that easily you can access it. Whereas hard link plays a very important role when you have a very, very critical file and you fear that maybe by mistake, if it gets deleted, I'll lose the data. So what we'll do, we'll create a hard link and keep it. You can create soft link for a file also. You can create soft link for a directory also. But in case of hard link, remember my point that hard link is only and only creatable for files. Hard link is not allowed to be created for the directory. A directory cannot have hard link. Directory can only have soft links if you want. So soft link is creatable for files as well as directory. Hard link is only and only creatable for files, not for directories. I hope you have understood the concept. Once you do practicals with your own, you'll be very confident about it. Now let's move ahead and let's talk about a very, very beautiful command, grep command. Regular expressions, pipelines, and other concept is there. The first command, what we are going to talk about is grep. Grep stands for global regular expression print. Now, what does this mean? Suppose, guys, I have a file which have lots of data inside it. Lots of lines are there. One of the example I can show you is etc password file. Now this file contains users information. Please never ever try to edit that file. I'm only taking it as an example to read the file. You can take any file you like and do this experiment. As this file is already having lots of data, I want to use this file. It contains users list, how many users that are created in the system. So there might be many users, system users, normal users, super user, many type of users are there. So if you see that it's having a good data inside it, too many lines are there. Now guys, if I want to find a particular name inside this file, how tough it would be. If I want to read or if I want to find a particular name, maybe I want to check only those lines which have a word called root. I want it to display only those lines which contains a word root. Why should I see the whole file when I can see a specific line of my choice only, right? So in order to do that, we'll use grep as a command. So you can ask grep, search me a string. So whatever name you are mentioning, it is called as string, a word. Search this word in a file etc passwd. So when you ask it, grep will go to that file. It reads the whole file for you. Wherever the word root is found, only those lines it will print. So how beautifully it has filtered for you. Now, if you do it manually, you need to read each line concentratively, whether the word root is there or not. And then you have to deduce it. So it makes very complicated to read manually, where grep is making the same thing easy for you. You just ask that read the file and show only the lines which contains this word root. If you want, you can also print line numbers by adding an option hyphen n. You can say grep hyphen n, show me the line numbers. What are the line numbers of those found words? So it says one word is found on line number 1 and the other word is found on line number 10. So in the same file, wherever that word is there, it will read and show you. So if you do it with cat command, you have to sit reading the whole file. So grep is filtering, reading for you and printing those lines which contains the word called root. Parallelly, you can search the same word in two files. So I'm telling grep, print also line numbers, search a word root in my first file etc password and in the second file etc shadow. So I'm going with two files, guys. Do not worry what is this file, what does it stores. I'm taking it as an example. If I don't do it, I have to create a file, I have to write the data. So I'm just taking a random file and I'm asking search that what is there inside it or not. So you see it is telling in etc password there are two lines, line number 1 and 10, which contains the word root. Whereas in etc shadow there is line number 1 which contains the word called root. So parallelly in multiple files you can search a word. So it reads multiple file and show you whether that word is present or not. So how much simplified it has done your work. Now let's move ahead and let's see more beautiful options in grep. The next thing what I want to show you is, suppose I want to search multiple words in the same file. Maybe 2, 3 words I'm looking. So I'll try first of all like that. Grep. If you want to print line numbers also, then go with -n. If you are not interested in line numbers, no need to add -n. I want to see line numbers. So I'll say grep -n. I want it to search two strings. First string I want it to search is root, and another string I want it to search is my user. In which file? The file name is etc shadow. So try to understand what I'm doing. I'm asking grep to look for two words, root and my user. In which file? In etc password, pass wd. Now when I hit enter, you see it is showing me the word root. But in case of my user, it is telling my user no such file or directory. So guys, why it has found root and at the place of my user, why it is telling no such file? The reason is grep is thinking that I have to look for a word root in a file my user and another file etc password. So it is thinking I have to search one word in two files where I am searching two words in one file. So it is not understanding that my user is also an expression what I am looking for. It is thinking my user is also a file in which I have to search for a word root. So guys, how can I tell grep that there are two words to search? It is not a file, it is a word I'm looking for, an expression. So you can use a command grep-n to print line numbers. First expression I have to use with -e root. Another expression, one more time -e. E stands for expression. What is the expression? My user. In which file? etc password. Now it will understand that root is one expression and my user is another expression. So did you see it found both? If this name is not present in the file, it won't print anything. Suppose I give a name that is not present, so it is not going to print anything. That name must be present, then only it will print it. Okay, so like that you can search more than one word. For example, I want one more. So I'll go for -e SSH. So you see it found SSH also. So you can grep out multiple expressions, multiple strings in a file or multiple files also you can do it. Now guys, here there was three expressions, root, my user and SSH. So it was so simple for me to search. What if I want to search 5 expressions at a time? Then to search 5 expressions at a time, you can go with a different option, grep hyphen capital E. If you want to see line numbers, then add -n. N will print line number. E for expressions. Small e is single expression. Capital E is multiple expressions you are looking for. But all the expressions, whatever you are searching, you need to search within single quote or double quote. I'm using single inverted quote or single quote. First word I'm looking for is root. Now, how to differentiate between multiple words? I cannot just type everything like that, isn't it? So between each word, you have to use pipe symbol. How to use pipe symbol? See, normally when you click on backslash, it will print backslash. But same backslash, if you print with shift, shift and backslash will give you pipe symbol, modulus or pipe, whatever you call. So I'll use pipe. First word is root, second word is my user, third word is SSHD, fourth word is FTP, fifth word is nobody, like that. In which file? The file name is etc password. So I'm telling grep command to look out for all these words in etc password file. Now when I hit enter, you see it found root, FTP, nobody, SSH, my user, all of them. So like that, you can go with grep command and search for multiple expressions in a single file or multiple files. You can add second file address. It will do the same search in your next file as well. So like that, you can look out for a single file or you can look out for multiple file or one word or multiple words as per your requirements. Okay, now let's see little more things when compared to other things. Now let us say that um, I have this file, hard file. Now in this file, I would be looking for a word called link. I don't want to read the whole file. I want to search only that word which is having link inside it, that line which is having link inside it. So I'll say grep for me link in which file? Hard file. So you see wherever the word link is found, it is printed. But did you observe there is a line which is starting with link and there is a line which is also having link. There are two links. Why it showed only one link? Why not the other link? Because one link is completely small letters, what I have mentioned. The other link is starting with capital L. So it is not matching the case. Let me make it more interesting. I'll go to that file and I'll add one more thing called soft link. So I'm giving one small letter, one starting with capital letter, and the last one is completely capital letters. So I'll say grep, show me the word link. So when I say small letter link, it is looking for small letter link only. If I give capital letter L, it is only showing me that line. If I give completely in capital letters, it is going to show me only that. So exactly what pattern you are giving, the same pattern it is searching and showing you. So I want to break that pattern. I don't care whether it is in capital letters or small letters or mixed letters. In any case it might be, I want to print it, whether it is capital, small or mixed. So in that scenario, you can go with grep-I, where I stands for inverse grep or inverted grep, or not inverted, I'm sorry, case insensitive. I'm so sorry. It's not inverse, it is insensitive. That means disable the sensitivity of my search. So don't go for a pattern, whether it is caps or small, print everything. So case insensitive, guys. So which is that file you're looking for? I'm looking it in hard. Now you see whether it is in small letter or starting capital or complete capital, it is showing everything. So this is the way you can insensitive your search, whether it is caps or small, doesn't matter, print everything. If you find a word link in any format, capital letter format, small letter format, or mixed letter format, whatever it might be. So that's how we can search for a file or for search a word in a different formats. Now, one more thing is there, guys, what I actually wanted to tell you was inverse script. That's accidentally came out of my mouth. So what is that inverse grep? See guys, in a file, I have a word called link. So I don't want to see that lines which is having a word link inside it. Maybe I want to read the whole file, but I don't want it to display that line which contains a specific word called link. Up till now, what we were doing, guys, we were looking for that specific word and printing it. Now I want to look for that word and hide from the output. I'm telling print the whole file, but don't print that line which contains the word link. How can I say? I say grep hyphen I to make the search case insensitive. Then I'll say V. V is for inverse. I'm telling that don't show me that word link in the file called hard. So wherever you find the word hard, hide that line. Wherever you find the word link, hide that line. So you see earlier, all those three lines were printed, link, hard link, soft link. But in the current output, do you see any line containing the word hard? So what it does, it printed the whole file for you by hiding that word. So you can hide a word and print the whole file, or you can only print that word what you are interested in instead of reading the whole file. So both are possible with the help of grep. So inward greps is not that much used, but normal grep conditions, whatever I have shown you, is very, very useful. Now, grep can be used as a direct command, or grep can be combined with other commands also. For example, guys, I have a command. Now, this command I'm going to teach you in detail when we go for software management. So as of now, I don't want you to worry about what is this command, what it is doing. Just concentrate on the output. So when I run rpm-qa, it actually displays how many software are installed in your system. Now guys, your OS will be full of software. So if you just view the output, it's keep on going and going and going and ongoing. Around 2000, 3000 software might be installed. So output was so big that it washed away so fast. Now what I wanted to do in that output, I want to search something. Now, if I sit searching manually, it might take a long time for me to search a word. So what I'm telling here is whatever output RPM command is producing, don't display the whole output. From that output, I'll order grep. Whatever output is getting produced, search me something with this name. So how can I combine two commands? You have to use pipe. Actually, pipe is used to combine two commands. You might have seen that in our gardens or something, you might have pipes. One end you will be connecting to tap, and from the other end you will be watering the plant or garden. So that pipe has two ends which will connect two things. So same way the pipe will also connect two commands over here. Whatever first command output is there, it will be presented as input to second command. So condition will be from the output of first command, grep me something. So whatever output RPM is producing, from that output, I'm ordering it to grep a word called sudo. So guys, instead of me searching that word, it says from the output of RPM, I found two lines which contains a word sudo. Anything it might be. Or maybe I'm looking for VIM. See how many files are there or how many softwares are there with the name VIM. Or I can say look out for SSH. See, so this is the way, guys, how you can combine grep with other command. Whatever blah blah command it might be. It can be simple cat command also. You can say cat etc password. When you say cat etc password, it reads the whole file. So from that output of cat command, I can say grep for root. So whatever output cat command is producing, from that output, it can search. So you can directly use grep on a file or whatever command you are running on the top, you can grep it. For example, there is one more command, lshw. LSHW stands for list hardware. It will read the entire hardware configuration and print it for you. See, lots of output has been produced. Now, I'm not interested to see the whole output of LSHW. I'll say from the output of LSHW, grep me a word call, for example, um, RAM, or if RAM is not there, can I say CPU, for example? See, so it is showing me all the details about my CPU. Or you can go for another word called memory. So it might show me the details if there is a word available called memory, right? So like that, you can use grep with combination of other command. So don't worry what lshw will produce. I just use it as an example. Here you have to concentrate that from the output of that file or that command I'm searching. If I don't know this, then the whole output I need to look out. Where is that thing? So grep will filter the things and show you only that thing in which you are interested, right? So it can directly use on a file or it can be combined with other commands. Now let's move to our next beautiful filter commands, which makes our life very easy. Now filter, I don't have to explain you what it does. Same like grep with more different scenarios, you can go for less, more, head, tail. And there are other commands also, which I'm going to talk later. First of all, let me talk about less, more, head, and tail. See guys, let us say that you have a file or an output of the command that's too lengthy. Like we saw RPM, QA, LSHW, the output was very big. Or if you simply go to etc password file, read it. When I hit enter, if I start by going with -n, you see 47 lines are there. And from where I am able to see? From line number 11. So what happens to previous 10 lines? See guys, the output was so big that it rushed the previous 10 lines and moved to 11 to 47. So I was not able to see those previous 11 lines. Now here the output is 47 lines. What happens if the output is 400 lines? It would go so fast that you will not be able to see all the previous lines. So my requirement is I want to read this file, but slowly, line by line, page by page, like that. So you can use less prompt. When you say less, see these commands are reading the file, but different. Cat command will rush and go away, but less will read the file and stop on page number 1, which is the file etc password. When you say less read me a file, it start with line number 1 and wait it for you so that you can read each lines as per your requirement. Now if you want to move ahead, see it has displayed first page and waiting for your instructions. If you hit enter, it will take you to next line, next line, next line, or simply you can use up arrow or down arrow. If you use down arrow, next line, down arrow, next line, down arrow, next line, up arrow will bring you up. Or you can directly go page by page. How to go down to next page? You can use D. D will take you down to next page. How to come back to previous page? B to come back to previous page. So you see, when I say D, it will take me to next page. There were only 2 pages. I reached the end. At the bottom, it is displaying that you are at the end of the output or end of the file. To go back previously, I'll go with B. B will take me back. D will take me down. B for back, D for down, right? So like that, I can move line by line or I can move page by page. Suppose you want to search a particular expression like grep. So you can use / and you can mention which word you are looking for. Suppose I'm looking for a word called root. When I hit enter, it highlights all the lines that have a word root. You can do N, same like VI editor, N or B, it will take you to that word. So any word you are looking, you can search it. The beauty of less command is it will not leave the file until unless you ask it to leave. It will stay in the file until unless you type Q. So when you type Q, as soon as you type Q, you will be out of the file. Q is for quit. So less end the file. D for down, B for back, down arrow or enter to go down, up arrow to come back. Q for quit. That's how you can read a file in less prompt. Same like less prompt, but little fuzzy. We have more. More is very anxious fellow. As soon as the reading is finished, automatically it will leave. Most of the option works. So if I go more etc password, see, you can use down arrow to go down or hit enter to go down, B for back, D for down. But you see, as soon as it reaches towards the end, suppose the file is come to an end, observe at the bottom that automatically it will come out. So when I say D, as soon as you reach to the end of the file, it is going to bring you out of the prompt. Less will make sure that you are staying inside the file until unless you are asking it to leave it. But more thinks that okay, the file is read, so I should be out. So as soon as you come to end of the file, automatically more will leave the file. That is the only difference between less and more. Otherwise, both will do same thing. Now there is no good practice, bad practice, or who is better, who is not. You can use both. Now both can be used with a combination of other commands. For example, if I say rpm-qa to list all the software installed, the output is very big. Now I want to hold the output and only see what I'm interested in. So I'll say rpm-qa, then you can say pipe less or more, whatever. So whatever output RPM is producing, pause it. So you see it took us into less prompt. Now you can hit enter, 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 or down arrow, up arrow to go up and down, D for down page, B for back page. You can search a word, for example, open SSH. If it is found, it will show you. Suppose you're looking for a word called SSSD, something like that. It would show you. To come out, Q. Anything, if you say LSHW and maybe more. So whatever output LSHW will produce, it will stop and display you the detail. What is what? Okay. So this is how you can use less and more. Either you can use it directly on a file or you can combine it with other command. Why it is used? To pause the output of the file or the command so that you can see from the beginning what is what. And there are shortcut keys D for down, B for back, forward slash for search, all that. Now we have another set of command, head and tail. Now guys, head represents something which is at the top, isn't it? And tail represent something which is at the bottom. So head will also read the file. Now these are all file filtering commands, guys. It will help you to filter the output or file and show you top something, bottom something, something like that. Suppose I would like to see top 5 lines of any file. So you can say head followed by the file name. Suppose I want to see top 10 lines, so I'll say head and the file. It is only and only going to display top 10 lines, starting from line number 1 till line number 10. Now, same like less or more, you can use head command as a direct command, or you can combine with other command. So I want to show you line numbers. Line numbers can be printed with cat command, right? I'll say cat hyphen n etc password. So when I say cat, it will read all the file. I'll say don't read all the file. From the output of cat command, just show me headlines. So headlines are what? Top 10 lines. You see it is starting from line number 1 and printing till line number 10. Suppose I want to see only bottom 10 lines. So I'll go with tail. When I go with tail, it is showing you last 10 lines of the file. So top 10 lines can be viewed with the help of head command, and bottom 10 lines can be viewed by going with tail commands. Head will show you top 10 lines, tail will show you bottom 10 lines. But what if I'm not interested to see 10 lines? I want to see maybe top 3 lines or bottom 50 lines. Maybe output is very big. So I'm interested to see a customized number of lines. So you can say, show me only top 10 lines, head hyphen n, where n is number of lines you are interested in. So I am interested in 3 lines. So just type 3. So you see it is showing only top 3 lines. What if I want to see bottom 3 lines? So I'll go tail hyphen 3. If you wanted to go with top 9 lines, it will only show top 9 lines or bottom 9 lines. So head hyphen number of lines or tail hyphen number of lines. This is the way how you can use head and tail to filter and see only the required amount of lines from the output. Now it can be anything, direct command, or you can use it with other commands. Okay. Now next command what we are going to talk about is sort command. Sort is a very simple, straightforward command. There are no things to be discussed. Sort, as the name itself is telling you, it is going to arrange the output of any file as per alphabetical order. Suppose I have this file, or maybe I'll go with a small file, which is hard file. It has number of lines limited. So I have around 9 lines in this file if you just read it. Great. Now what I wanted to do here is I would like to arrange the output with respect to alphabets. Something which is starting with A should come first. Then something which is starting with B should come next. Something which is starting with C should come next. Like that. I want to arrange the output with respect to alphabets. So I can go with sort my file. So you see, as per alphabetical order, H should come first, then L, then N, then O, then S, then T. So it has arranged the output with respect to alphabetical order. Nothing changed in your file. Your file is still working with the same format. If you read the file, nothing has changed. It only modified the output and showed you that if you arrange according to alphabet, this is the correct order, right? So original file is not going to get disturbed, only it produces the output and show you that this is the correct order as per alphabets. Now suppose your file is having some numbers. I'll go to hard file and let me put some number. For example, I'll say 9, then maybe I'll put 7, then I'll put 5, then I'll put 1, then I'll put 4, then I'll put 3, then I'm going to put 8, then I'm going to put 6, and maybe the last one which is missing is 2. So you see 1 to 9 lines I have kept, but observe the numbering I have given: 9, 7, 5, 1, 4, 3, 8, 6, 2. So this is not proper alphabetical order, sorry, numeric order. Now, if you want to arrange the file with respect to numbers, then you can say sort hyphen D. D stands for digits. So you will arrange the output with respect to digits. So you see it has arranged the output with respect to numbers inside the file. So the correct order it is showing is 1 to 9. That is the way. So if your file is having starting numbers or something, to arrange the output with respect to numbers, you can go with sort hyphen D. So that arranges the file, or that arranges the line with respect to numbers. That's how we work with this sort command. It's a simple command, guys. There is no complication. It just arranges the output as per alphanumeric order, whichever you want. All right. The original file is not going to get changed. Changes are made only in output. So it is harmless. Nothing is going to get changed in your original file. Now, next command, what we have is cut command. Now, this is also a very interesting command. Guys, cut command is used to cut the output and present into columns. Suppose I have employee details file. Now that employee is having name, employee ID, employee salary, etc. Guys, just give me a minutes of break. We'll start after the break. Just 1 minute. Stay tuned. Okay, guys, let's continue. So, as I was telling you, cut command. Cut command is used to cut the output of a file or output of any command into columns. So as I was telling you, suppose you have an employee file details which contains many employees detail. One column is having employee name, other column is having employee ID, other column is having employee salary, email address, and blood group, etc. So every time I'm not interested to see the whole file. I just want to see only two fields. Maybe I can say cut employee name and employee ID for me. Don't show anything else. So that's where cut command will come into the picture. It is going to cut the output of the file into columns. So how to cut? The best example again I can use is etc password file. So see, it contains lots of fields. You have username, user ID, different fields are there. So maybe I'm not interested to see all the fields. I just want to see first field, just display usernames. That's it. Don't give me any other detail. So how can I cut the output into one column? You can say cut command -F. Each column is represented as field. First field, second field, third field, fourth field, fifth field, like that. So all the columns are cut into field. Columns are called as field. If you are interested to see field number one, just say show me field number one. From which file? The file name is etc password. So you see, it is not showing me one field. It is displaying the whole output. What did I ask it to do? I told show me field number one, but it is displaying the whole output. Why is that? Where is the mistake I am doing? See guys, here it is not understanding where the field is starting and where actually the field is ending. It is considering the whole output as one field. So I need to point towards a mark that is separating both the field. If you see, each field is separated by a special character colon. First field colon, second field colon, third field colon, fourth field colon. So can I not use that colon as a marker or a field separator to tell cut command that wherever you find colon, treat it as a file separator or field separator. I'm sorry. So this is something that separate two fields. According to that, you divide the file. So I'll say cut, but according to a delimiter. That special character that separate two fields is called as delimiter. So it is going to divide two fields. So what is that delimiter? Colon. So I'm telling, wherever you find colon, treat it as a field separator. According to it, separate my file and show me first field only. Now did you see, am I getting only first field? Let me make it even more interesting. I'll say tail, just show me last 5 lines of etc password. Whatever output etc password command is producing, tail command, from that output I'll say cut with respect to a delimiter colon and show me field number one. You can give D space colon or D colon or hyphen F1 or hyphen F space 1. Space or without space will be treated same way. So you see, instead of showing you the whole output, it is only showing you field number one. What if you want to see field number one and field number three? So you can say F1, comma 3. So it is going to show you field number 1 and then field number 3. How about field number 1, 3 and 7? So you can say 1, 3, comma 7. So 3 fields it is showing you. Like that, you can cut the output of a file and see only the fields in which you are interested. Instead of seeing the whole output, you can cut the output into columns and you can see. But guys, here you need that special character in the file that divides two fields. So fortunately, etc password was having colon. So I used colon as a delimiter. If some other file is having hyphen, I'll use hyphen as a delimiter. If some other file is having star, I'll use star as a delimiter. So whatever special character it might be giving, all special characters can be used as a delimiter, whichever is separating two fields. But suppose if I have a file, something like this. Now guys, in this file, do you see any special characters that is separating two fields? See, there is simple spaces that is separating two fields. In fact, I'll remove that hashes and all whatever is there, dd to delete the line. Okay. Now, if you see now, this file is just having simple spaces that is separating each field. Every field is separated by space. Now guys, how can I cut this file into pieces or in fields? Can I say cut, show me field number one for my file? It repeats the same thing. I don't understand which is field. So I'll display everything. Now I need to set a delimiter. Guys, if delimiter is star, I'll put star as a delimiter. If it is ampersand, I'll put ampersand. Cap, I'll put cap. Percentage, I'll put percentage. How can I put delimiter as space? How to symbolize space? That is the question. To symbolize space, you need to say hyphen D. If you don't give anything, it will throw error that you should type some character as a delimiter. How to put space as a delimiter? You need to use either single quote or double quote. Between them, you have to give space. So cut with respect to two quotes with a space. Show me field number one. Is it working now? Now you can use single quote or you can use double quote. There is no difference inside it. Same result you will get. Now suppose I want to see field number 1 and field number 4. So I'll say field 1, comma 4. So if any field is having fourth field, it is going to definitely display that. This is the way how you can cut the output into columns. If you have a special characters, you can simply mention that special character over here. It will cut accordingly. If you don't have any special characters, simple space is there. So you can put that space within single quote or you can put it into double quote. So that is it guys for today's session. I think we have seen too much. So I want you to practice this. After the class, I'll be sending you the recorded sessions. Watch it, work with the lab manuals and all, and practice it. If you have any further questions, any doubts you are facing, please let me know now before we stop the session. All right, so it seems there are no questions as of now. So you do practice and then let me know if you have any questions or queries. Thank you very much, guys, for joining this session. See you tomorrow for next session.